Astronomers recently made a shocking discovery. Regarding the constellation Botans, the megastructure of galaxies and galaxy clusters spans 1.3 billion light-years. It is a giant circular shape, and scientists call it the Great Ring. The object is located more than 9 billion light-years away from us. It is therefore very dark and invisible to us. If the Great Ring were brighter, we would see a stunning pattern in the night sky. 15 full moons with a large luminous circle. But astronomers were shocked by something else. A huge arc of galaxies 3.3 billion light-years away from us, along with its neighbors, has again challenged the standard model of the universe. Both objects may be part of a connected cosmological system. Then they go beyond the limit, which should be the same in all directions. There are many other contradictions in the currently accepted structure of the universe, so scientists are offering their own variations. Sometimes they sound like science fiction. However, there is scientific evidence to support each. Let's take a virtual space trip to the most amazing of these worlds. In fact, we will encounter a huge celestial mixer, a terrifying black ocean, and strange cosmic holograms. What else can researchers surprise us with? We won't be the first to wonder about the structure of the universe. Humans have been asking the same questions for a long time. One of the world's oldest civilizations, Mesopotamia, divided everything into 3 parts back in the 20th millennium BC. The first contains the underworld of the god Ea. Above it are Bel's land holdings. Finally, the celestial realm of Anu covered everything. The second world is above ground. In Mesopotamia, they were a circular barge propelled from beneath a mountain. The sky followed the shape of the earth, and the 2 parts were separated by a celestial ocean. The sun in this model moved from east to west, as did the stars, always following a fixed path. Ancient Egypt had no shortage of exotic ideas about the universe, and each of them was necessarily connected with higher powers. In one of the most unusual versions, the firm was considered a lotus, and its center, the center of the world where the gods live. Later, the ancient Greek philosopher Aristotle concluded that the planets and even the sun revolved around the earth. In the 16th century, Nicolaus Copernicus believed that the earth revolved around the sun and was the center of the universe. But we won't dwell long on the past. At that time, scientists could only see a small part of the sky through primitive telescopes. Others were supplemented based on religious and philosophical considerations. Now the ideas associated with new scientific discoveries have lost their significance. We will turn to the perfect concepts of cosmology. Over the past few centuries, scientists around the world have collected a huge amount of data to support various hypotheses about the structure of the universe. In the 20th century, more advanced telescopes revealed to people the true vastness of the cosmos. At the turn of the century, the American astronomer Harlow Shapley mapped the Milky Way. Above, the sun is one of 100 billion stars in a dark corner of the spiral arm of the galaxy. In 1929, American astronomer Edwin Hubble proved that there are thousands of galaxies in the universe. So our case is not unique. With these and many other discoveries are now associated versions of the structure of the universe. The most reliable and plausible is the standard model of the universe, which is hot, fairly uniform, and homogeneous in all directions. The hypothesis was first proposed in the 1920s by Belgian scientist Georg Lemaître. Since then, modern science has added a lot of convincing evidence to this version. Let us briefly recall its essence. According to the hypothesis, the universe was born from a singularity as a result of the Big Bang. During the first few seconds after the event, the energy density was infinitely high. In this environment, there were only fundamental particles, leptons, quarks, and DARs. As the universe cooled and expanded, atoms formed and then combined to form galaxies, stars, and their systems. According to this theory, the universe is one and unique. It has no interaction with it, and in relation to it, such concepts as mass, shape, and size lose their meaning. Density, pressure, temperature, and chemical composition would be more accurate. Our complex world, however, bears little resemblance to the simple gas that these concepts can describe. Astrophysicists, for example, have encountered the expansion of the universe and the relic background. The nature of the first phenomenon is the gravitational influence of all things. Its development determines the future of the universe. The second is the remarkable legacy of ancient epochs, when light stopped interacting with matter and separated from it. Now, because of the expansion of the universe, most ancient photons have moved from the visible to the microwave range. These are called relic radiation, which serves as one of the main arguments of the Big Bang theory. There is evidence that the early universe underwent a period of cosmic inflation, expanding at an increasing rate. Our universe is still expanding, farther and faster than we are. Moving to smaller scales, we can trace the open cellular structure of the universe. Inside the cells are spaces, cosmic voids, and their walls are made up of galaxies, including spiral, lenticular, irregular, elliptical, and active nuclei, including superluminous quasars. Galaxies contain dark matter, cosmic rays, interstellar gas, and many celestial objects such as stars, planets, and black holes. The same physical laws apply to all of them. For example, scientists hypothesize that gravity, electricity, magnetism, and light behave the same way even in the most remote regions of space. Thus, the source of energy for quasars far from us is the accretion of interstellar gas to the supermassive central black hole, which is quite clear to experts. Such lights are incredibly bright and can be seen from the farthest reaches of the universe. The oldest gamma-ray burst detected by astronomers is GRB 090423. It took about 13 billion years to reach Earth. In other words, the damage occurred just 630 million years after the Big Bang. The universe does not obey uniform physical laws. It is generally homogeneous because the energy of the Big Bang smoothed it out in all directions, and the expansion continues to smooth out the vast cosmic fabric. Of course, the mass of galaxies and clusters in different regions of space varies. However, on average, given the size of regions millions of kilometers across, the mass and composition would be the same. You can clearly visualize this by digging over a large field with a shovel. Some shovels of soil will have large rocks, others will have worms, and still others will have more clay than before. But every 100 shovels will be about the same in composition. It is more difficult to imagine how space travelers will see the cosmos in the depths of space. For example, the farthest known exoplanet is 3,000 light-years from the Sun, about the same distance as Earth. All in all, according to the Standard Model, our world appears to be well-appointed, vibrant, and unique, without chaos or confusion. It is undoubtedly breathtakingly beautiful. But a number of recent studies refute this surprising view. What are the experts questioning? Today, scientists describe the universe using two main hypotheses, the general theory of relativity and quantum mechanics. The general theory of relativity shows the influence of gravity and the structure of the universe on large scales. That is, it extends from a few million to billions, or 24 zero kilometers. The last number is the size of the observable universe. Quantum mechanics describes systems on very small scales, on the order of millionths of a centimeter. However, these two theories are incompatible because gravity does not exist in quantum mechanics. Scientists are now searching for a hypothetical particle called gravitons. If they were discovered, the theory of quantum gravity would solve the problem. But that hasn't happened yet. Without gravity at the quantum level, all planets and stars would have to disintegrate into atoms. In addition, some studies show that some parts of the universe are growing faster than others. Consider megastructures from galaxies, the Great Ring and the Road of Giants. They're already out of line with that theory, exceeding the allowable size. But there are much larger formations, and among them the record holder is the supercluster. The galaxies, the Great Wall, Hercules, the corona, the Arctic sky. Its diameter is about 10 billion light-years, so it covers almost the entire universe, which is 13.8 billion light-years. In general, it is impossible to explain the existence of the Great Wall within the framework of the basic model of the universe. Thus, the thesis about the homogeneity of the universe is called into question. Scientists are trying to find a solution to this puzzling contradiction. Recently, South Korean cosmologists have created the most advanced and ambitious model ever. These 400 billion objects make up about 2/3 of the total mass of the universe. The diameter of the model is about 10 gigaparsecs. With the help of modeling, experts set out to reproduce the evolution of the universe. And most importantly, we're studying cosmic structures, a similar topic to what we've been talking about. Scientists believe they are the remnants of waves of very hot cosmic plasma. Over time, they cool down and seem to freeze into the cosmic structure, creating a supercluster of matter. Studying such structures is only possible through computer modeling of most of the universe, as it extends very far from us. The scale of the South Korean scientists' models allows them to do this, unlike previous simulations. Perhaps, after the completion of their research, astrophysicists will make changes to the basic model of the structure of the universe, or even create their own. However, there are many such hypotheses, and some of them are so unusual that they will drive you crazy. What do you think of the idea of living in a pancake universe? Is it cold or cool? Either way, you have to understand this. If this is true, New York mathematician Edward Kasner. He first proposed his theory of the creation of the universe in 1921. His universe is beautiful. There is neither gravity nor anti-gravity. Or in other words, space has no Einstein cosmological parameters. It is a completely empty world, and nothing seems possible. However, Kasner recognized that his hypothetical universe would expand equally in all directions. It expands along 2 coordinate axes, but the third is narrow. In this case, the geometric shape of space resembles an ellipsoid stretched in 2 directions, but in the third direction, it is increasing day by day. Thus, the configuration of the universe gradually becomes a flat pot, but it doesn't get lighter over time. On the contrary, its volume increases. The whole secret is that Kasner's universe was not born from a single point, but as if infinitely thin. Its initial radius is infinity on one axis and 0 on the other 2. But what is the secret of this empty world evolution? As its space changes in different directions, gravity is created. This determines the development of Kasner's world. In other words, it would grow in one direction, and over time, the volume would increase proportionately. But we see this in space. Kasner's universe can only exist if it is completely empty. If something is added to it, it will gradually begin to become a unified universe. Although Kasner's world has different densities as it moves, its curvature is the same at any given moment. At the same time, the general theory of relativity allows the universe to evolve at different speeds and with different curvature over large portions of space. Models using this assumption were developed by American mathematician Abraham Tubb in the early 1950s. This changed Kasner's universe. Its spaces can be open in some directions and closed in others. According to this version, space is more than just a ripple. Sometimes it turns itself inside out. But how does this happen? It's all about gravitational waves, which dramatically deform space. They change the geometry of space from spherical to saddle-shaped and vice versa. In general, these things seem strange and unthinkable to us, but mathematically, they are possible. No wonder the universe is filled with a kind of celestial churn. But what forces can turn a vast area into some kind of homogenized cocktail? In 1967, American astrophysicists David Wilkinson and Bruce Partridge discovered that relic radiation is heated equally in any direction. The change in temperature is less than 0.1%. This suggests that although our universe was not completely homogeneous at birth, it was very soon. According to one hypothesis, the eccentricity of the early universe was gradually dissipated by neutrino gravity. That's what's called friction between its parts, caused by the exchange of neutrinos and light streams. Such stickiness could quickly mitigate the initial chaos in the cosmos. But the authors of the idea didn't agree with everyone. Any process involving friction generates heat. Therefore, the energy density of the cosmic microwave background radiation should differ significantly from the observed value. In further research, astrophysicists found that gravitational processes could only remove the tiniest cosmological inhomogeneities. Other mechanisms were needed to fully balance the universe. They were discovered by a team of American astrophysicists as part of the theory of inflation. Scientists have called their world a Sunbeam Products home faucet. It sounds rustic, but homely. However, peace and comfort do not await us as we travel through the world of the kitchen. Mixer saddles are constantly rocked and whipped with great force by certain forces. Who are they? According to the idea of the authors of the hypothesis, this light spreads along very long but closed paths. Thus, everything in the space is mixed and homogenized. After testing this model, it was confirmed that photons do travel long distances. But as a mixer, light particles are not as efficient as expected. However, the mixmaster universe has some remarkable qualities. It emerges from a zero volume, expands to a certain maximum, and then shrinks again under the action of its own gravity. In such a universe, evolution is completely random and therefore cannot be accurately predicted. At a young age, such a world changes dramatically, constantly changing its shape. It expands in two directions and contracts in the third. In this respect, the model resembles Kastner's beet-shaped universe. However, the directions of such expansion and contraction are not constant. They change places randomly. In general, the mixer universe shakes and jiggles like jelly on the hip. Such deformations can be interpreted as the phenomenon of gravitational waves moving in different directions. And these waves are much stronger than in Kastner's model. The mixmaster universe is considered one of the most complex fantasy universes in the history of cosmology. At the same time, this does not contradict the principles of the general theory of relativity. Scientists are now trying to combine this concept with quantum mechanics and superstring theory. In this case, the Italian researchers suggest that we should not get stuck in jelly, but travel the vast ocean. Do you need a boat to travel through such a universe? Let's take a look. The hypothesis of cosmologists about the universe and the oceans is related to spatial dimensions. There are three basic ones in our world. The fourth addition is in the form of time. According to some theories, time is more than just an abstract frame. It contains physical objects. For example, on the scale of the universe, there are planets, stars, and galaxies. Hence, we can visualize the universe as a four-dimensional space-time. Just as water is made up of countless molecules, at a deeper level of reality, it is made up of microscopic particles. In general, The idea that time feels like a fluid is not new. The theory of excess vacuum was proposed more than half a century ago, but Italian physicists were the first to question the viscous properties of such matter. How everything in the universe moves is one of the most difficult mysteries of cosmology. For example, a wave travels through water, using it as a medium for propulsion. In fact, any energy transfer requires a medium. So how do electromagnetic waves and, for example, photons move in the cosmic vacuum? This paradox is explained by the theory of excess space. Fluids with zero viscosity behave as one. Of course, such an infinitely flowing and energy-free space seems like pure fantasy. In fact, such fluids exist. A superfluid is a substance through which a liquid or gas can flow. These properties manifest themselves when it is cooled to absolute zero, or minus 273 degrees. In this state, atoms lose their individual properties and act as a single superatom. However, these very real fluids have truly remarkable properties. The most famous of the superfluids, helium, is like ordinary transparent water. However, it manages to escape by climbing the unsealed walls of the ship. It cannot be heated. Such liquids transfer heat almost perfectly and vaporize when the temperature rises. Recently, British physicists conducted an experiment to find out what the effects of a quantum superfluid are. They immersed a special finger-sized probe into a helium isotope cooled to the right temperature. The superfluid helium behaved very strangely. Its surface formed an independent, two-dimensional layer that apparently radiated heat from the rod. The underlying liquid beneath this layer acted like a vacuum. It was completely passive and totally unimpressed. In other words, the only part of the liquid that interacted with the probe was the two-dimensional surface layer. It defined all the properties of helium. The Italian physicist's theories treat spacetime as a superfluid with zero viscosity. The model shows that this strange matter is not forced to rotate in one direction as in normal communication. At zero head, the fluid disintegrated into individual small vortices. Scientists believe that such quantum tornadoes explain the formation of galaxies in the universe. We'll also have British astrophysicist Jamie Farnes, who studies the fluid in the universe. Only its universes are permeated by other flows, dark matter and dark energy. But don't think we'll be entering a world that looks like an ocean of hopeless ink when we travel. Dark matter and energy are called dark because their existence has not actually been discovered yet. These are hypothesized dark horses. Their existence is indicated by the absence of matter and energy in space. Many galaxies are spinning so fast that if they were made of ordinary matter, they would disintegrate. But it isn't. It is hypothesized that these objects are held together by an invisible halo of dark matter, and that the universe would not be strong enough to expand as it is now without an energy source. It is calculated that dark matter and energy would gradually lose their properties and strength as the universe expands. Assuming that the dark universe is filled with flowing liquid, everything comes together. The authors of the hypothesis believe that black matter also has a negative charge and repels other matter. In other words, dark energy and dark matter are the same matter with negative mass effects. We will have to take into account the unique properties of negative mass during this cosmic journey through the universe. If you have to keep it away from you, it will work out completely unexpectedly. It would encompass us as it accelerates its movement towards violence. The theory of the existence of negative matter existed before, but most scientists have not supported this. Such mass is thought to lose density as the universe expands, and it contradicts observations that show the persistence of dark matter over time. The dark fluid hypothesis resolves this contradiction because it assumes the constant emergence of new negative masses. So the liquid in the Farnes universe does not melt or lose its properties as it expands. His idea has been confirmed by a new model by Japanese researchers. Using data from the Subaru telescope in Hawaii, scientists have created a large-scale map of our universe. It provides the most detailed picture of the distribution of dark energy in the universe. For example, it has allowed astronomers to measure the gravitational perturbations of about 10 million galaxies. Modeling also shows the formation of a galaxy with a negative mass of 45,000 around a galaxy with a positive mass of 5,000. It is worth noting that in the Farn hypothesis itself, Einstein also talked about the need to change the cosmological constant. According to him, there should be negative masses scattered in space. Thus, the great physicist may have predicted a world filled with the opposite of ordinary matter. Farnes's fluid universe of dark matter and dark energy develops this idea of Einstein's. However, this hypothesis has one flaw. If negative masses appear to be constant in space, they should be symmetrical in positive and negative qualities. But astronomers do not observe this. To better understand everything, researchers are now testing Jamie Farnes's hypothesis with the powerful radio telescopes of the SKA Observatory. Meanwhile, a group of Dutch physicists have come to a very different conclusion. According to them, the influence of dark matter and dark energy should not be overestimated. So no one knows in what environment the universe originated and why it is moving faster and faster in different directions. Dark energy, which no one has ever seen, is not the only explanation for this process. Physicists from the University of Copenhagen in the Netherlands believe that universal cannibalism is to blame. Agreed. There is a lot of noise. Scientists confirm that it is a very violent process. According to them, our universe regularly encounters newborns and then absorbs them. It is this kind of charge that allows the universe to accelerate. Scientists have drawn similar conclusions based on a mathematical model. Thus, our theory of absorption of nascent universes better fits the picture observed by astronomers than the dark energy explanation. According to research, the process of merging with other universities increases our global reach. This can be seen as an extension of current scientific tools. The theory also solves the problem of cosmic inflation. It is believed that in the first moments of the universe's creation, a mysterious, superfast expansion created some hypothetical field, an influx. But the Dutch researchers show that the process begins with the absorption of our newborn world by a larger, mature universe. After that, the new, larger universe kept bumping into the children's university and swallow them, getting a new energy boost each time. Cosmologists consider this theory consistent and logical, but it also has a few shortcomings. For example, the authors of the hypothesis do not give a detailed description of the horrors of the cannibal universe. In this sense, it is difficult to determine whether such a scenario can explain the inflation of the universe and its rapid expansion. All of this can be confirmed by observational data. Many experiments are currently underway to study the properties of the microwave background. Perhaps their findings will help determine the reality of university mergers in the near future. Or scientists will find that in many worlds, many things happen differently and off-script. Universes can be completely bloodless and not absorb each other. Instead, they live in harmony and can grow side by side, but each separately. Contact between the two is still inevitable. But what will it look like? Imagine seafoam where each bubble is a separate universe, and our universe is one of them. How do proponents of the multiverse theory envision things? There could be an infinite number of these worlds, and they would be completely different from each other. And each will have its own laws of physics. Float among cosmic stars, galaxies, and black holes. They might even have intelligent civilizations. U.S. cosmologists were inspired by the theory of cosmic inflation. According to them, inflation did not end everywhere at the same time. Sometimes it has stopped in some regions and continued in others. In some regions of space, this process continues to this day, creating new interstellar universes. To understand how it works, you can imagine a universe with rapid growth processes like water boiling. Excess energy causes something, space-time, to change. As a result, bridges, new universes, are formed. If they turn out to be small, they quickly disintegrate, and the released energy leads to the birth of new worlds. But if the universe's bubbles are strong, they grow and expand until they burst. The energy of an explosion is also used to form a new world. That is, the multiverse hypothesis repeats the Big Bang theory, which began the expansion of the universe. But our explosion isn't the only one. It's just one of many. Now scientists are trying to find new and stronger evidence for the hypothesis. For example, if the neighboring bridge of the multiverse was next to ours, they could collide with each other. Then, after the catastrophe, our world would have left a tangible trace. This trace can be seen in the strange properties of galaxies where the event occurred, or in perturbations of the cosmic microwave background. Such evidence could be a cold spot of cosmic microwave background radiation. This is the name given to the supervoid Eridanus, which is 3 million light-years from Earth. Supervoid is very cold and dark. There are no stars or galaxies in this supervoid. None of its deep rays illuminate its fathomless depths.